Good morning, students. So today's class we are going to study the third chapter, the about the FIR filters, finite impulse response filters. So what is meant by FIR filters? The filter having finite number of samples of impulse response. We call it as FIR filters. So in this FIR filters, we are going to study about the design of linear phase FIR filter and its general consideration, and we are going to study about the filter design using various windows, and we are going to compare the performance of the various windowing techniques. Then we are going to study about the filter design using rectangular window, Hanning, Hamming and Blackman window. Then about the frequency sampling method. So now let us have a short introduction about the FIR filters. The features of FIR filters. The first one is the FIR filters always it is having the linear phase response. That means the angle is linear in the case of FIR filter. And FIR filter is always stable. Why compared to IIR filter? Because it is not having any feedback. If it is having any feedback means if there is an error in the output that will be fed back again to the feedback as a feedback to the input side. So due to the non-feedback nature, so FIR filter is always stable. An IIR filter compared to the IIR filter. Then in the quantization noise, that means quantization noise is when you're converting the analog signal into a digital signal, there will be a chance for producing the quantization noise. So that may be negligible in the case of FIR filter. And one of the disadvantage of FIR filter is they need higher order for similar magnitude response of IIR filters. Then the next one is let us see what are the various steps involved in designing the FIR filter. So the first and foremost thing we have to choose the ideal desired frequency response which is denoted as HD of e power j omega. So you know for a low pass filter or high pass filter, band pass and band stop filter. So each filter having its own desired frequency response. So that we have to choose it initially. Then the next step we have to take the inverse Fourier transform of that particular frequency response Hd of e power j omega to get Hd of n. And then if you do this you will be getting a finite number of points here. Then the next step is the Hg of n. It is converted into infinite duration. That is convert the infinite duration Hg of n into a finite duration h of n. So that conversion takes place here. Then the next step you are going to take the Z transform of h of n to obtain h of z. H of z is nothing but it is a transfer function of a digital filter. Then the fifth step is you have to choose a suitable structure. You know there are different types of structures that are available in FIR filters like transversal structure, linear phase structures like that. So you have to choose a suitable structure and realize the filter. And finally we have to verify the design. So in order to verify the design we have to determine the actual frequency response h of e power j omega of the filter by substituting z equal to e power j omega in h of z and plot the magnitude response modulus of h of e power j omega. So these are the 6 steps involved in designing the FIR filter. And the advantages of FIR filters are FIR filters have exactly linear phase, so angle is linear, so it can be easily designed. The second point is FIR filter is not having any feedback, so that's why it is the effective realization of FIR filter exists at both recursive as well as non-recursive structure. Then FIR filters realize non-recursively because it is not having any feedback. So that's why the direct convolutions are always stable. Then the round of noise which is produced during the quantization process. So it is inherent in the realizations with finite precision arithmetic. So this can be made, the round of noise can be made small in the case of FIR filters. Then the disadvantage of FIR filter is the duration of the impulse response should be large to adequately approximate the sharp cutoff filter. That means the duration of the impulse response should be high. And so because we have to approximate the sharp cutoff filter. So hence large amount of processing is required to realize such filters when realized via slow convolution. The second disadvantage is the delay of linear phase FIR filter. It need not be always be an integer number of samples. there can be a non-integral delay, that is this non-integral delay. So these lead to some problem in the signal processing applications. So thank you.